Hi everyone, I'm Dr. N.Senthil Madasamy, Associate Professor, Computer Science Engineering. Great pleasure for me to welcome you all for learning this session. This session topic to be covered is approaches to cloud software recommends engineering under secure cloud software recommends for Unit 5 cloud security. At the end of Unit 5, the students will be able to outline software development for cloud using secure software design principles. At the end of the session, the students will be able to understand approaches to cloud software recommends engineering under secure cloud software recommends. Now we will see about approaches to cloud software recommends engineering. Cloud system software recommends engineering demands extensive interaction with the server, and the product of the process includes both non-functional and functional software performance characteristics. This diagram illustrates the major elements of the software recommends engineering process. This diagram illustrates additional elements that can be used to augment traditional software recommends engineering to increase cloud software security. Now we will see about a resource perspective on cloud software security recommends. Approaching software security requirements derivation from a resource perspective provides an effective method for addressing cloud software security requirements. In April 1995, a paper, Smart Requirements, take this approach by defining the following smart basic properties that requirements should possess. Specific, the requirement should be unambiguous and direct. Manion and Keepens define these characteristics as being clear, consistent, and simple. Measurable, the requirement should be measurable to ensure that it has been met. Attainable, the system must be able to exhibit the requirement under specified conditions. Resizable, the requirement must be achievable under the system and project development constraints. Traceable, the requirement should be traceable both forward and backward throughout the development lifecycle from the conception through design, implementation, and test. The Open Web Application Security Project OWASP has modified the SMART acronym to be SMART plus requirements. These requirements taken from OWASP website as follows. Specific requirements should be detailed as necessary so there are no ambiguities. Measurable, it should be possible to determine whether the requirement has been met through analysis, testing, or both. Appropriate, the requirement should be validated, thereby ensuring both that they derive from real need or demand that the different requirements would not be more appropriate. Reasonable, while the mechanism or mechanisms for implementing a requirement need not be solidified, one should conduct some validation to determine whether the meeting the requirement is physically possible and possible given other likely project constraints. Traceable requirements should also be isolated to make them easy to track or validate throughout the development lifecycle. Now we will see about goal-oriented software security requirements. Another complementary method for performing cloud software security requirements engineering is whole-oriented paradigm, in which the whole is software objective. The types of goals that are documented are functional goals, non-functional goals, security robustness, and code correctness. One implementation of goal oriented requirements engineering is the non functional requirements framework, which provides a basis for determining if a goal has been satisfied through meeting lower level goals. Non functional requirements include characteristics of a software system such as reliability, performance, security, accuracy, cost, and maintainability. According to Koesel and Vinokraт, these requirements should specify the following. First one is properties the software must exhibit. Second one is required level of assurance or risk avoidance of individual security functions and constraints. Third one is controls and rules governing the processes by which the software will be built, deployed, and operated. A related goal-oriented requirements engineering approach is the MILOS project methodology for goal-oriented security requirements engineering. The MILOS security model uses generic specification patterns that map to information systems properties of the confidentiality, integrity, availability, privacy, authentication, authorization, and non-repudiation. Now we will see about monitoring internal and external requirements. Two types of secure software requirement analysis should be performed. First type is internal, necessary in order to ascertain that the requirements are complete, correct, and consistent with related specification requirements. The analysis should address the following: security concerns, the software's non-functional properties, the software's positive functional requirements. Second type is external, necessary to determine the following: the software assurance requirements address the legal, regulatory, and record policy issues. The non-functional security requirements represent a proper decomposition of system security goals. Software assurance requirements don't conflict with system security goals. The software is resilient. In the context of internal access to information systems, the issues in the table should be considered are: maintain identity of active users, implement internal access controls, use secure gateways to allow internal users to connect to external networks, hide internal domain name systems, dial-up modems should not be connected to computers that are connected to the internal network. Email messages flowing through the information systems should be monitored. In the context of external access to the information systems, the issues in the table should be considered are: external connections must be incorporate adequate controls to safeguard IT resources. At a minimum, all external connections must incorporate a firewall. If the user access originates from outside the protected network, the user must be identified and authenticated at the gateway. Use external authentication databases such as Radius. Employ content filtering to permit or deny services to specific external hosts. Accredit external connections prior to use. The summary of this session: we learned approaches to cloud software requirements engineering under secure cloud software requirements. I hope you found this lecture is more informative. Thank you and have a nice day.